right, we are back for part 2 of problem 16 of Advent of Code 2022. Part 1 was a doozy. It took several tries, several sessions before I realized with a hint from someone that there actually are a lot of valves that don't release any pressure, which allowed us to simplify the problem substantially. Part 2, you're worried that even with an optimal approach, the pressure release won't be enough. What if you got one of the elephants to help you? It would take you 4 minutes to teach an elephant how to open the right valves in the right order. I'm skeptical of that, but okay. Maybe elephants are smart, but 4 minutes seems fast. Leaving you with only 26 minutes to actually execute your plan. Would having 2 of you working together be better, even if it means having less time? Assume you teach the element before opening any valves yourself, giving you both the same full 26 minutes. In the example above, you can do it like... With the elephant helping, after 26 minutes, the best you could do would be to release a total of 1707 pressure. With you and the elephant working together for 26 minutes, what is the most pressure you could release? Cool. Puzzle input is the same. Okay. So. The idea here, and let's just think. So we have 26 minutes, and the elephant and us. So my first thought is that it doesn't. The first question is whether it matters, whether order matters when we compute the optima. Or like whether we have to compute them simultaneously or whether we can just compute one and then compute the other. Because obviously the elephant, we are symmetrical with the elephant. So obviously it doesn't matter who we treat as the elephant, who we treat as us. I'm going to name the elephant Timothy, by the way, Timothy Elephant. Doesn't matter whether Timothy Elephant starts or whether we start. And the question is, can we just solve Timothy Elephant's problem and then solve ours, or are they interconnected? Obviously they're interconnected in the sense that we can't visit the same node. We can't open the same node. But I think proposition we can compute the optimal path for Timothy Elephant first and then ourselves. I have this wrap somehow. Alt-Z, okay. Without loss of generality. How would I prove this? So suppose sum x sub n is the solution for Tim. Then that's the fastest path thing to spend 26 minutes on. We start at the same place. So a bad case would be one where, let's say we have a really good, let's say that right off the bat, AA to just potential counterexample. let's say A to B, C, where A has 0 flow, B and C have 100 flow. Calculating Timothy's path first. He goes B to C to done, because suppose everything else is 0. But with us, we would go, he goes A to B to C. We would go A to C, getting 1 extra minute of C. Okay. So it's false, because this is a counterexample. Right? If A leads to both B and C have 100 flow, everything else has 0 flow, then having 2 of us, we can in parallel do better than if we calculate his path first. Okay. Interesting. So therefore proposition is false. So, question, what if we change our depth-wise search to be breadth-wise? Does that help? Well, the idea would be with breadthwise, we can explore both where we go and the elephant at once. It's sort of not clear how that would work. Yeah, so parallelizing is worth something. And so we can, so at a minimum, the solution space is like almost squared as big as in the previous example. So we can say certainly we can just say at each point, look, here are all the places that the elephant could go. And here are all the places we could go. And we keep doing it depth-wise. The nice thing about breadth-wise is we can explore the elephant at once, and therefore eliminate visited nodes at once. That's the nice thing, because if you go depth-wise, you have this problem where, okay, the elephant goes a bunch of places, and that eliminates options for where I can go. But of course, I was about to try to say something that maybe isn't true. Yeah, I kind of like breadth-wise, because otherwise you have the elephant do his whole path, and he makes a bunch of choices that you could explore really deep down. Like, if we take this example, you're going to do a lot of exploring of the case where, like, Timothy goes to both B and C before you ever explore the case where Timothy goes to B and I go to C on turn 1. So breadth-wise seems like it's probably better. And it's pretty simple. Then just every time we visit, my mouse is running out of batteries and is flashing at me. It's very distracting. Each time we do the breadth-wise search, we walk, like, we're in a state where we've visited a bunch of nodes already. We walk all of the other nodes in all permutations. Which maybe isn't that different from depth-wise, actually. Let's just try it depth-wise first, because it's easy. Because we already have depth-wise in here. And let's see what happens. So, somewhere in here we have the maximum flow. So we want to do something similar, but with two visitors at once. I'm thinking about whether I can factor something out of this. Basically, it's the same function, except that when we iterate, except that we have two positions. And it has a whole other, has a whole different function signature. So let's say get maximum flow with elephant. Unvisited looks the same. Time remaining looks the same. Current position can stay the same. Elephant. view size. Max so far can be the same. New max so far is now the sum of this and elephant position. Time remaining doesn't change. New max so far doesn't change. Unvisited. So unvisited, we now need to get both. We need to get permutations of. So dot permutations 2. We will never visit the same thing twice. We will filter such that the distance from, ooh, this is interesting. Okay, so we don't do this filter here anymore, we do it inside. The idea being this filter keeps us from looking at things that are too far away, but we don't want to filter both. We want to filter only one. So instead we say we'll say let new current position or new position, new elephant position is V0, V1. Those are guaranteed to exist. We can copy them. Now we want to say, okay, so now we have to handle each case. Let's see here. New unvisited is just I is not equal to new position, and I is not equal to new elephant position. Ooh, okay. But this is an issue. New time remaining is not going to be equal. New time remaining is not going to be equal. Same amount of time. So they happen in different time streams, so to speak, which is a problem now because the unvisited nodes are also get out of sync with one another. So like if it takes 5 minutes for me to go to my first place and it only takes 1 minute for the elephant to go to his first place, now my visited and his visited are different for those 4 intervening minutes. Very interesting. Very interesting. Okay, let's go back to the drawing board. So I feel like this should simplify somehow. But that's 100 times t minus 1 plus 100 times t minus 2 is 100 times 2t minus 3. Whereas this is 100 times t minus 1 plus 100 times t minus 1, which is 100 times 2t minus 2, which is bigger. Yeah, parallelism is worth something here. Does breadthwise search help us at all? Even breadthwise. Okay, so problem to overcome is that under our current model, a 15 node graph with weighted edges for how long it takes to traverse them, between Timothy, elephant, and we will go out of sync with each other. It becomes difficult to track visited versus unvisited. So obviously one idea is to iterate for minute by minute and trivially exit if nothing's happening that minute, which I think is an option. That way we get to keep one collection of unvisited nodes, and we do things whenever whenever one or the other of us visits a node. I foresee some issues with that, like now if I'm in transit to a node and the elephant is considering his nodes, I don't want the elephant to try to go there. But okay, we can imagine having light speed communication, and we can just tick off the unvisited nodes when we start walking there. Anything wrong with that? I don't really think so. In this case, unvisited needs to be updated as soon as an agent moves towards a node. Really feels like there should be something simpler though. Curious what happens if we do one, if we compute one and then the other. Yeah, parallelism has to buy you something. Starting from the end help us at all? If you're at the end, then you're always in the case where you just both. The problem with that is that there are now 15 times 14 different states that we can be in the end. Okay, let's do the minute by minute thing. So that means, let's undo some of this. That means we don't necessarily have a current. That means we don't necessarily have a current position or a elephant position. We can have a current target and a time until target. See anything better, so let's do that. Let's create a simple enum that we will just call enum or struct, I guess. Vector plan. Sure. Plan will be a U size for the destination and a time until you get there. And we will have a proper struct. Destination or target. ET, estimated time of arrival. Not distance. Or time remaining. Say time remaining. Target U size, time remaining. Time should return a self. We'll say tick, self, doesn't do anything, time remaining. Equals, if time remaining equals 0, then 0, else. Time remaining minus 1. Okay, now with the elephant, we do current plan. How do I keep writing play? Elephant plan. And we have to handle the various cases, which we can probably do in a helper function, which might be where we can actually generalize this. Maybe. So let's have a function that's called visit valve, and it will be, we'll take a self, it will take unvisited. Now it's gotta be recursive. Whole thing has to be recursive. So we tick first, yeah? So if current plan arrived, then we need let mute max new max so far b max so far new max so far plus equals this guy. Current plan dot target. We'll do a similar thing. For the other one, elephant plan arrived. Plant target. If we're done, then we return. And then there are 3 cases here. So if current plan dot arrived, then we basically do this. Let's return this, and actually we're going to want to do the first condition first. If elephant plan arrived, current plan arrived, and elephant plan arrived, then we need to do one set of things. Otherwise, and then something similar there. Just to get it to shut up. Okay, let's just do arrived bool time remaining equals 0. Okay. And here we will say let current position be current plan target. And now this works. But we want maximum flow with elephant. We want time remaining -1 -1. Let new plan be this. New plan. Elephant plan get ticked. And new plan is plan new. Current n in this. change tick to get ticked and have this take self and return a new self. And we'll say self target is, or we should really say self new, self target time remaining, and we'll return that. Okay. So the thing that's a little clunky about this is that we're going to repeat this function basically 3 times in spirit, but just symmetrical versions of it. And I'm trying to think how to factor it out. Okay, I have an idea how to factor it out. So what if we take this and we say, actually not pub, function visit with elephant. It'll be a self, it'll be a bunch of other things, it'll return a AU32. But it will take a hash set, I guess, or a vector, it doesn't really matter. A hash set of usize, representing toVisit, and then it'll presumably take a bunch of this stuff. Something like this, which is a lot of but the point will be that then we can just, when we want to call this just for the elephant or just for us, we just pass in a hash set that only is that's like the same target. But then I guess we have to compare the plans. But still, I think it's better. So we're going to return to visit iter. We're not going to do this filtering. We're going to say new unvisited is unvisited net of both of these. So we can into this if we want to. And these probably need to be dereferenced. If they don't. Usize, usize. Oh, it's already a usize, usize. Right. So we can just say, yeah. So we can just say current target elephant's target. Get rid of this. But any case where either or both of them, you know what? We actually can do that filtering. We actually can do that filtering. But we have to say current target elephant target, and then current position or current target, and this needs to be current plan dot target. So that certainly has to be true. And the equivalent thing is going to have to be true. Elephant plan and elephant target. Okay, those things have to be true. New unvisited, we will filter down to look I should not be equal to current target or and I should not be equal to elephant target. Let's just pop that out for readability. And then new time remaining, we're subtracting off 1 no matter what. We're gonna have to think about this. So yeah, so no matter what, when we call this, we are going to, we only call this when we are passing, let's see here actually, we only call this when we're, ooh, there's another issue here. So if, let's say that the elephant is arriving 1 second after we're arriving, then we need to spend that 1 second. We need to have a way to spend the 1 second. So I guess time remaining is always just n minus 1. But we can have our plan. We can have our plan have one more. Okay. So new. I kind of want to rename current to player. So let's do that. Just in here. Right, that didn't rename it up here. Okay. Wait, why didn't it rename it here? Oh, it only does it. It only does it once per line, doesn't it? Without the global flag. G. Okay. Okay, so new player plan is plan player target. Get this player target unwrap, but we need to add 1 for the fact that we spend a minute. Self distances player, and we need to check whether the player has actually arrived. So if player plan has arrived, then we do this, and player position is just player plan.target. Otherwise, this is just player plan. And the same thing for elephant. this becomes, oh wait, no, player plan dot get ticked. And dot get ticked. We need time to tick down. And this becomes new player plan, and this becomes new plan. And new max so far. Needs to be updated. That's true. I guess this can just be max so far. But now new max so far doesn't exist for this. But we can just pass in new max so far at the beginning of this. Okay. And that means that now these guys become the to visit, be unvisited dot into iter, or even iter. Dot permutations to collect, and now self dot visit with elephant. Those things. And let's also rename this. And this is going to be upset with me because of something about references. usize can't be built from vectors of usize. For sure that's true. Map v0 v1 collect. Okay. And then same story here, but we no longer have to do permutations, so we can just say unvisited iter map I, and this is the players arrived, so we'll say I, and then this is elephant plan dot target. And same story here. Here it becomes player plan dot target I. And what's wrong with this? Because we haven't returned else new max so far, yeah. Okay. Let's see how we do. So problem 16b will be very similar. Valves, graph, nodes with flow, get maximum flow, nodes with flow. Let's say until eruption part 2, or we can say minus minutes spent teaching elephant. And this is going to be, whoops, this is going to be with elephant. Player plan will be the 0th index with no time remaining. Should be fine. Same with the elephant plan. Max so far is 0. Time remaining is correct. And what's the issue with this? Oh, it's that we're returning the wrong thing here. Okay, and then we just need minutes spent teaching elephant const. Minutes spent teaching elephant, time 4. See how we do. From B passes, that doesn't make sense. Problem B can't pass because we don't know the answer for problem B. So it's coming out as 0, basically. Or something. Oh, or we just haven't. Hang on. It's because I never implemented the test. Yeah, it's because there's no example and then it's coming out as 0. Okay. So this is now 16b. And this is whatever it says in the question, 1707. And, okay, it's gonna fail and say that it's 0. So let's jump into the debugger and see what it doesn't like. And let's just go ahead and jump straight into get maximum flow with elephant, which for some reason I can't. Let's test solves or test problem. Put a marker here and debug. Okay. So max so far. If we arrived, which we have, we add, but that's fine. Time remaining is not 0. We have arrived. So we expect to pop in here. Which we do. To visit has like 30, which seems very plausible. I expect it to be 15 times 14. Wait, unvisited. Oh no, right, 6 times 5, 4 in the example. Okay. Visit with elephant. And so here, can I jump in here? elephant. Okay, these are now in place. Okay, so now the max so far is 0. We're trying out. The player goes to 2. The player target goes to 3. We did some filtering, which is probably good. They can't be going to the same place, which is fine. New unvisited, we expect to have 28 elements now. Or 4 elements, I guess. New unvisited has length 4, good. New time remaining goes down by 1. New player plan should go to that place, but it's going to take 1 longer than that. Player plan, time remaining, new player plan, variable is optimized away. Okay, new player plan, he's got a target, time remaining, seems reasonable. Elephant plan. I mean, in both cases, we get a new time. And maximum flow with elephant. Okay. Next tick. Elephant hasn't arrived. So nothing happens. Okay, but in the case where nothing happens, okay, time is just ticking down, but we're not ticking the plans down, is the problem. So, in this case, we still want to say let toVisit be player plan dot target wait, no, that's not right. Yeah, that works. Right, let toVisit be player plan dot target elephant plan dot target to iter collect, and then something like this, but with, in fact, something so much like it that it is that. B fails because we called unwrap on a none. Sure. How can these distances ever return none? Isn't it? Oh. It's if the plan and the target equal the same thing. Um, so this would be .or, .else, .unwrap, or player plan dot time remaining -1. Expected U size, found U size. Okay, and we do the same thing here. Or elephant plan dot time remaining. -1. Okay. Attempted to subtract with overflow. Time remaining, sure. So maybe it's just time remaining. Well, it's not though. Okay, but we can put the +1 in here. +1. But now we're adding to an option which we can't have, so we can say .map x +1 and .map x +1. Shoot, what did I do? I've done something terrible with parentheses. Self distances get that looks right. Unwrap or no wait, I need to get first. And then I need to map. And then I need to unwrap. Or. And then that needs to map to filter. That looks right. So I need to get. And then not unwrap here, right? Get. Map. Unwrap or time remaining. Cool. And the problem with this is that it's already a U size. Okay. Let's try again. Fails. Okay, but it fails for a better reason now. Better reason. We got an answer. We got a pretty quick answer. So, first off, let's read the question again. Do we and the elephant both start at A? Yes. We have 26 minutes. So we're saying, look, we only care about the nodes that have flow. Maximum flow, max so far. Seems good. New max so far. Oh, not that. What's this one? New max so far. We add the pressure if anybody arrived. If that happened, if there's no more to visit, or if time remaining is 0. But this is ending us a little soon now, right? This is ending us a little soon because unvisited will be empty, but we don't want to exit yet. So what happens if we don't exit at all and we just let this tick? I think it's fine. It'll just tick down. Okay, still fails. Okay, still too low. And that was the same number as before. Okay. So if the player and the elephant arrived, then we try having them go to every permutation. If the player only arrived, then we try sending the player to every new unvisited and continuing to send the elephant where it was going. If the elephant only arrived, then we do the converse. And if nobody arrived, then we just keep them going to their targets. That all seems okay to me. So then in here we say, look, if you'd better be distance +1 away at most. Seems fine. And then we say new unvisited is removes the two things that you've decided to target. Note if they're not already present, they don't get removed, which is fine. New time is one less. If you've arrived, you get a new location to go to. Otherwise, you just keep going where you were going, but your time ticks down by 1. And the same thing with the elephant. And then we recurse. And if we filtered everything out, because every option passed in was such that the distances remaining were greater than the time remaining, then we just return new max so far. All seems good. All seems good. Okay, let's step through it with the debugger because I'm sure I'm missing something. Obviously, I'm missing something. And just to triple check, let's make sure I pasted the right number in. 1707. Okay. So, first things first. We decide to visit 3 and, or I should say player target 9 and 3, which are J and D, which are very reasonable to visit. We have 6 potential targets before this. We already saw that we go down to 4, which is correct. Time remaining steps down by 1. Is this an off by 1 error with time somehow? Ah, yeah, it is. Or at least I think it is. So the issue is we're saying we've arrived at 0, or at AA at the beginning, but AA doesn't have any flow. So what we'll do is say time remaining, and we'll say let time remaining be this, plus 1. And reason being, add 1 in order to not wait for 1 minute at AA, which has flowed 0. So there's an assumption in here. Oops. fails. Okay, we're getting closer though. Probably. Probably. Actually, though, I don't think that's right. I don't think that's right because it's the plan. We have the 1 minute in the plan, and so we're not going to wait for 1 minute here. So that's not right. That's not right. This time remaining will tick down. Okay, let's write a simpler test. Let's write a simpler test. Let's say test computes optimal. Computes path with elephant. And let's say let input be Beck. What's the easiest way to do this? Do I have a case like that? So AA can go to BB, DD, or II, which has 0. Okay, so if I use the main, if I use the original example here, like this, but I say, this, but with AA, max so far is 0, nodes with flow, I grabbed the wrong one. I wanted this. But time remaining will just be 2 so that we can step and open. And let's say let solution and assert that solution is equal to, and what should it be equal to? So it should be equal to, we step, we open, oh, it needs to be 3 seconds. But then it's going to be 13 plus 20. So this doesn't need to be mutable. And this fails. We get 0 on the left. Not what we would expect. So, honing in on the issue. So, new max. We've arrived. We're not at time 0. Both things go, so we visit. When we visit, we have elephant target 1, player target 2 as an option. Time remaining is still 3. This all makes sense. Let's go. To here. So new player plan and new elephant plan are the things I care about. New elephant plan. Your target is B, which is 1 away, and so your time remaining is 2. New player plan, your target is C. Shouldn't it be D? We can't go to C. Why are we looking at C? Oh. Right. We're not using the right combinations of things, so we can't just... Oh, we can. We can visit all of the unvisiteds. But it should get filtered out. That case should get filtered out, because we shouldn't be close enough. Because we only have 3 seconds. So why was that not filtered? Why was that not filtered? So the new plan is to go to C, no, to D, and to go to three is D, and 9 is J. Okay, D and J, these make sense. These make sense. And this should work, right? So here we're going to 9 and 3. And new max so far already has 9 and 3 in here. So new max so far would work. But we're saying we get a new target. New target is to go to should have taken 2 to get there though. Event plan. No, we've popped out. We've popped out. That's not good. These are different targets. We shouldn't have popped out. So why are we popping out? happened on my breakpoint? Okay, so we're going to A and D. Or, no, E. And E. Okay, so this should never happen. Whoa, why is time remaining 25 here? Time remaining should be... Hey, Dundiff. Yeah, doing AOC. I didn't start it right on time, and I haven't been doing it every day, so... working on it on a bit of a delay, but I've been enjoying it. Although at the moment, I'm confused about elephants. Thanks for the follow. How's it going today? That's what I was just looking at. I was looking at why my test. Did I click the wrong? I probably just clicked the wrong test. Yeah, okay, timer is 3. Doing well. Still doing it too, no worries. Doing AOC in new language is challenging, in your case, Clojure. Yeah. Clojure, doing some of these in Clojure seems, doing some of these in any functional, like I try to use a functional style, but as you can see, even in my functional style calls here, filters and maps, I still end up breaking out into more statement-based code, or whatever the opposite is, procedural, I guess. But it's a lot of fun. Which one are you up to? Plenty left to visit. Time remaining ticks down. We get new plans. All of this is fine. Time remaining is now 2. This player plan will never happen. This elephant plan will never happen either. Time started at 3. Y is going to 10. Okay, something is out of sync with my time remaining and the plans is the thing. So when I visit, so say I start at 3. When I visit, I decrement. So I think I'm adding 1 here for the time that we will spend opening the valve. But I'm also decrementing, which means that visiting is taking 1 time. This plan was at 0. We visit. Yeah, so I think we don't need the +1 here, because visiting takes 1 unit anyway. Is it fun? Rust? Yeah, I love Rust. Doing AOC in Clojure instead of JS this year is a very nice experience so far. Functional style somehow helps creating solutions at scale, meaning you don't have to write as much code for the second part. It's usually, yeah, I feel that way about Rust also, but I definitely feel that way in general about functional styles. I try to, as I said, I try to use a functional style in other languages, so I don't do much JavaScript. I've done some TypeScript, and even there, if I can work out how to, then I try to use a functional style. And I do it a lot in Rust. And I think somewhat similarly, the compiler, one of the things about Rust is the compiler is really hard on you. I mean, it does a lot of things. It infers a lot of things for you, which is great. You can see the type hints being put in here. But it also, forces you, and I'm sure Clojure is the same way. It like forces you to make sure that everything is the right type. And I think that has a similar effect to what you're describing, where it's like you get to the second part of most problems, and it's like pretty easy to generalize. I actually think in the case of this particular problem, I feel like I'm missing an easy generalization, and I may have gone down a little bit of not a dark path, but this feels a little bit overwrought to me. But at this point, I'm close enough to solving it that's okay. Let's try this again. Fails on. Okay, we're off by 2. That's a really frustrating number to be off by. Okay, and our test passed. Our shorter test passed. We're off by 2. Really, 2. Okay. We're a little low. A little bit low. So, okay, so we've tested the case where they have something to do on turn with all of their time. Let's check. I suspect that somehow one of the cases where like the elephant has something to do with its time, but we've run out of time, or like we have nothing useful left to do, I suspect that there's some off by 1 issue or something in there. Okay, so like if we give ourselves 1 more second in our test case, then the elephant's gonna go to D, or one of us should go to D, and one of us should take the extra 1 second to get to J, because then we get a 21 instead of two 13s. No, actually that won't quite work. The two 13s will be better. Two 13s will be better. Is there some point at which that's not going to be true? If we take one more second after that, then 321s should beat out two 21s should beat out three 13s, yeah? 3 times 13 is 39. 2 times 21 is 42. Okay, so if I give it 5 seconds instead of 3, or 5 minutes instead of 3 minutes. Let's see here. Let's just copy this over. And we'll give it 5 seconds, or 5 minutes. And we expect the answer to be 20 times 3 plus 21 times 2. As opposed to 20 times 3 plus 20 plus 13 times 3. Assuming I'm doing my math right. Okay, we got a failure. 104 versus 102. Oh, I think that's just me copying it wrong. 21 and 20. No, it's not. So, but we're actually saying we can do better somehow. Can we? So, we certainly can't get to H. H is really far away. So we can get to BB and it can be open for 3. We can get to DD and it can be open for 3. We can get to CC for 2, doesn't help. EE for 2 doesn't help. And we can get to JJ for 2, and that should be better. 20 times 3, 21 times 2. 20 times 3, 21 times 2. That seems right. Okay. Dundiff says, you've done AOC in Ronda.js. It was a nice experience too. Maybe do this year's AOC in some library, like FPTS 2 after you're done with Clojure, since you want to get good at TypeScript too. What language are you programming in usually? Yeah, so for work stuff, mostly it was Python and PySpark in particular, some Java, but I do a lot of data stuff in Python, but Rust has been my language of choice for anything I get a choice in for a while, and so I really love Rust. I don't think it's that hard. I don't think dealing with the compiler borrowing, the error messages are so good, and you have to nail down 1 or 2 hard concepts. They're not even that hard. Like, you have to be explicit with yourself about what's going on, but Rust is very explicit with you about what's going on, and so it's not too bad. If you try to borrow something multiple times, Rust says, hey, look, you're trying to borrow this multiple times, and then you look at it and you say, oh, okay, from Rust's perspective, why shouldn't I be allowed to do this? And it's like, I've handed over references to 2 different functions Rust has no idea what I'm doing with those two different functions. I could be mutating that data, in each of the functions. Rust doesn't want me to do that. It's looking out for me. Okay, so I see that. I need to fix that somehow. I'm going to clone one of them, or I'm going to put them in separate blocks so that Rust can tell that I'm not doing, that the scopes don't overlap, that I can't be mutating them at once. And I think it's kind of, it's one of these things where, like, people think there's a flip side to languages that don't challenge you on those things, which is, in Python or JavaScript, it's very easy to pass an object into a function, mutate it, not realize it, and wind up with some like behavior you didn't expect. And I personally would rather I'd rather find out at compile time that I'm potentially making one of those mistakes than, when it's running on a server somewhere, finding out at runtime. But I can see, I'm not a purist about these things. I quite like Python also. I'm not such a big fan of JavaScript, but not for that particular reason. There are lots of upsides to having looser languages than Rust also. I quite like Elm for doing front end stuff. Most of the stuff that I do in the front end, which is not very much at all, I use Elm, which compiles down to JavaScript and has kind of a similar thing to Rust, where, and it's functional, so you might be interested in it. But it has a similar thing to Rust where the error messages are really, really good, and because of that, it can be really, really strict with you in a super supportive way, where at the end of it, you're like, oh, thanks, Rust. I appreciate that you forced me to make my types line up kind of algebraically and didn't let me, just stick a null in there and run into a runtime error later. Okay. So I'm suspicious because my test is failing the opposite direction from the example. Right, because the example 1707 was the actual answer, and I was low. In my test, my actual answer is higher, which makes me think I'm just doing something wrong in my test. I'm giving it 5 seconds. It spends 1 second walking to B, D, or I. It spends another second walking to J. It spends a second opening. So that's 2 seconds. Should leave 5 seconds or should leave 3 seconds for DD and 2 seconds for JJ. 3 seconds, 2 seconds. I'm doing this right, I think. Okay. Let's comment some stuff out. These really should be in 2 different tests, but didn't do that. And my debugger is being very slow. Okay. So both have arrived at 0. That's fine. We visit the node. Bunch of stuff gets filtered out as not being findable. We target C and E with 2 seconds left. before we get there. Which I think is correct because we should be at... We're at A, so we can get to C in 2 seconds, or minutes, and we can get to E in 2 minutes. Then we have to spend 1 minute there. This is some nasty off by 1 error. This is some nasty off by 1 error. It's gonna tick down. Okay, the problem... That's the issue. Okay, so... Arrived means we've hit 0. But... hitting 0... If we set up a new plan... and the time to get there is 2, then we call get maximum flow. It's the 3rd time that we call get maximum flow that this procs. So because of that, whereas we want it to be the 2nd time. We should just tick the plans up here. Nothing stops us from doing that. Does anything stop us from doing that? No. New player plan equal player plan.tick get ticked. New elephant plan. Yeah, elephant plan.get ticked. This should be new. This doesn't actually matter, but every time we say player plan in here, we should say new player plan. Is that true? Yeah, that's true. Player plan. New player plan. Okay. And now we should not tick here. Bar checker doesn't like this. Yeah, so this is a decent example where before I was creating a new plan object out of player plan, and now I'm not. And the bar checker is saying, look, you're trying to you're trying to move this notion of player plan, don't do that. Which actually, it occurs to me I could just make the type copy. Oops. But usually I would just clone it there because I know I'm trying to create a new version of the plan, and so that's not a issue. Thanks for the detailed response. Make it Rust to Go. Actually, was that a pun? Because there's also Go, which is supposed to be cool. I've never done it before. On some free weekend or holiday, curious about it since there's lots of hype, but a bit resistance. It's always described as hardcore. Yeah, I don't know. I don't really think it's that hardcore. You've written a bit in it, but at the end you've liked closure more. Yeah, I think that's totally reasonable. I've never done closure. I do think Elm is like very anchored to front end, which since that's what I use it for, it's fine. But closure is obviously a more general thing. Do I like Rust syntax? I feel like it would have been better if they had chosen snake case convention for Rust or camel case. I do. I don't have a problem with it for the most part, as long as things are readable. I don't tremendously care one way or the other which casing they choose. So I don't have a problem with it. There are some things like enums I kind of tend to want to be all uppercase, but I understand why they're not. So doesn't bother me that much one way or the other. Okay, so did I successfully fix my issue? Visit with elephant. I also use sorry if I'm dropping frames. I also use, because I partially come from Python, like the underscore, the snake case is pretty natural for me. Okay. Okay, so getting a failure. Now we've gone way too big. But I think we're closer to identifying the issue. Let's bring this back. Actually, I don't want to debug that. I just want to run it and see what happens. Stop. Run. Okay, so we've gone too big now. I'm going to have to wrap up in a few minutes. So we check if the new one has arrived. Whoops, I missed a check. I also need this to be okay. Still failing. So, if we're about to arrive, then we do our visiting, and within our visiting, we don't ever tick the plan, which is good. Maybe this filter is not good now. New time remaining -1. Yeah, because now we're out of sync here. So now we really want new time remaining. In these filters. And maybe actually what I'll do is change this to new time remaining. Change these to new player plan just to new elephant plan. Everything should be on a new basis, really. Except unvisited. And then up here, new time remaining should be -1. I don't know why I'm writing this 4 times. New time remaining, new elephant plan. New time remaining is time remaining -1. And then all right, getting closer. Okay, unfortunately I do need to drop, so I think this is just an off by 1 error that needs to be traced. I might just solve it off stream, and then tomorrow when I'm back at 1 p.m. I'll just explain what the issue was, and we can get started on problem 17. Thanks, folks, for stopping by. See you tomorrow at 1. Diff, good chatting with you. Hope to see you again. All right, have a good one.